Anyone remembers what we are doing? Ankit, Ekansh, Manoj, Shami, Manish, anyone? But in the last class, what we were doing? Anyone? Sorry. Anyone remembers what we are doing?
So we proved big maximum principle and then Fourier transform.
So we are doing heat equation, right? So our aim is to study this type of equation, ut minus Laplacian of u equal to 0 in Rn or in some bounded domain or in bounded domain, and corresponding u at x0 is will be given if it is Rn f of x something and u of u of xt from g of xt denominator cross 0t kind of thing if it's a bounded domain. This condition arises if only it's a bounded domain. This we are doing, right? For that we have first we said something called Fourier transform. Anyone tried all those properties? Shami?
Oh, yes, sir, some of them.
Is it okay? Some are very
Yes, sir.
straightforward, right?
Yes, sir.
Okay. Define of z is equal to s dot z. Okay, and there are some property that we don't have to bother. The only one you should remember is the we have been using is that suppose let us say let us take fx is equal to some e to the power minus pi a mod x square with a positive. So is that a L1 function? Anyone? Is this an L1 function? Is this L1 or x in Rn? Yes or no? Is this an L1 function? Anyway, check this. This is an L1 function, okay? And if you take the Fourier transform of this function, then the Fourier transform function you will be getting is n by 2 e to the power minus pi psi square by s. These are known as a Gaussian function, right? You know, obviously Gaussian function. So this theorem says these things. If you are in the Gaussian, if you so this same kind of function you are in. Of course, the constants are different, but the properties are the same. So the Gaussian functions means you have probably studied probability theory. This is e to the power minus x square kind of function. So again, you are getting a function which is equal to minus constant times I square by a. It's the same thing, the e to the power minus cx square kind of function, right? So these are the Gaussian functions. So the important aspect of this property is that if f is a Gaussian function, then the Fourier transform is also a Gaussian function up to some scaling. Up to some scaling means up to some constant. Okay. So this is crucially used. You know why I am saying this, and also this property is used d alpha. If you take the Fourier transform of the derivative of f, then 2 pi I xi to the power alpha. This is just a integration by parts. The proof follows directly from the integration by parts. Okay. Another is something called inverse Fourier transform, right? If z is Rn e to the power 2 pi I x dot xi x. Okay. And I have asked you to check that if Fourier transform take the inverse Fourier transform, this is equal to actually you get the function itself fx, and which is again equal to f take the inverse Fourier and take the Fourier transform. Okay, so these are the properties we have used in proving. So then we study this equation. There are many ways to study, so I thought that you know Fourier transform. That is why I have used this path. Okay, so u solves this equation ut minus Laplacian of u equal to 0 in Rn cross 0 infinity, and u of x0 is equal to g of x when x is in Rn. Okay, so ut minus Laplacian of u equal to 0 in Rn cross n. We want to study this equation. So do you remember how we have studied? We have just taken a Fourier transform, taking Fourier transform of this function from left hand side, right hand side, here also Fourier transform with respect to in the x variable, because this is a function of xt in x variable, and then we get ut hat of x xi t, because t is a dummy, t is an independent variable, because I am not taking the Fourier transform only in x variable. So this is this plus 4 pi square psi square u hat xi t is equal to 0 xi in Rn t positive, and u hat xi 0 is right. So this is of the equation like this ut plus xi ut means if you just fix for a fixed xi, you just for a fixed xi, this is at plus some constant a function of t, let's say function of t, xi is fixed, some xi, okay, that is equal to 0, and this is a of 0 is given to be some a0 which of course depends on psi. So this is a simple ODE. You know how to solve this ODE, and you know how to do this. Okay. So finally we obtain that uxt will be given by, then uxt will be given by 1 by 4 pi t to the power n by 2. This is very important. By 4t convolve with these is known as the, and we define something called fundamental solution, right? Define the fundamental solution. Fundamental solution, that phi of xt is 1 by 4 pi t to the power n by 2 e to the power minus x square by 4t. X is in Rn, t positive 0 when x is in Rn, and t negative. Okay, t non-positive. So this is the fundamental. Sometimes in the book it is written also written as the heat kernel. Okay, this is something, sometimes in some book it is called heat kernel. Okay, this is one of the fundamental object in the study of heat equation. Okay, so this is used in, so it solves the equation. Suppose you are given ut minus Laplacian of u equal to 0 in Rn, okay, and u of x0 is equal to gx is given, then the solution is given by this, that 1 by 4 pi t e to the power minus mod x square by 4 pi t convolved with g, right? And these part for t non-negative, and it is 0, and it is this function is known as the fundamental, like the greens, like we have studied in the heat in the Laplace equation, the Laplacian of phi equal to 0. You remember in Rn minus 0. So for n greater than, you remember, right? This is minus 1 by 2 pi log of mod x if x not equal to 0, and sorry, of course for x not equal to 0 phi x is defined for n equal to 2, and some constant time x minus y 2 minus n for n greater than equal to 3. Okay, of course here for all n there is only one fundamental solution, which is given by 1 by 4 pi t to the power n by 2 e to the power minus mod x, the Gaussian type distribution. But of course this is t. So let us see this function in more detail, right? So whenever I will write for xt, that means I am writing 1 by 4 pi t to the power n by 2 e to the power minus mod x square by 40 for t positive. Okay. Okay. Now you tell me, how is this function? So what will happen as t tending to infinity? क्या होगा? When t tending to infinity, how the function will behave for fixed x? Anyone? Or some fixed x? Huh? Just see what are the prop whenever, because this
Goes
is very,
to like 0.
this goes to
0.
because where it is going, e to the power, e to the power for fixed x
Minus
it is going
infinity.
to, huh? For this goes to as t tending to infinity, 1, and this goes to 0 for any for any x in R, right? Yes, first property. Now tell me what happened when t tending to 0. Hmm? What happened to this function when t tending to 0? Yes? What happened? What?
0.
Pxt goes to goes to
I think so 0.
0. All right. For because for x not equal to 0. See, if x equal to 0, then this is a 1, right? E to the power minus 0 is 1. As t tending to 0, this goes to infinity, right? Yes or no? Yes or
Yes,
no?
sir.
Yes and no. Okay, good. So when t tending to 0, phi xt goes to 0 for x not equal to 0. Because if x not equal to 0, this will be the dominator because they're exponential. So this goes to 1 by e to the power minus infinity, right? So this is a exponential is more dominating than the polynomial. So this will be the behavior will be determined by this, and this goes to 0 faster than t going to 1 by t goes to infinity. This is very important to understand. So you understand that so phi xt has a problem at t tending to 0 when x equal to 0. So these are these. So there t when this function is nice or everywhere this function is nice, but it will have some problem when x equal to 0 and t tending to 0. So we have to be very careful with this two part. When x equal to 0 and t tending to 0, we have to be very careful for this function, right? Because it goes up to infinity. Clear? Okay. Second, do you know what is the integration? This you have done definitely in measure theory for fixed x. You some fixed sum x for fixed x. Not sorry for fixed t. What is the integration value of the integration? Hmm? For any t positive, what is the value of this integration? What happened? This you haven't studied in measure theory? What is the integration of e to the power minus a mod x square, some constant, this is some constant, equal to 1? This you haven't studied in measure theory? What happened? Manish, Shammi, Ankit, Ekans, Manoj, you haven't studied this? How to integrate integration e to the power? This is the first example of Fubini's theorem. How easily we compute this? No one have studied. Please tell me, Ankit, Ekansh.
No, sir.
You haven't studied this. How to integrate e to the power minus mod x square? Shammi?
No.
If I give you a hint, you can do this? Huh? If I give you a hint, you will try? What you will
Yes,
do?
sir.
You will what I'll tell you what you will. Don't worry. You write down z is equal to x by 2 root 3. ठीक है? Is that okay? Is that okay?
Yes,
ठीक?
sir.
Okay. Now you write down dz as, write down dz. What will be the dz then? 1 by 2 t half whole to the power n dx, right? Yes or no? Yes or no? Because this is the n
Yes,
variable.
sir.
So you will get, so dz will be 2 to the power, so 4 t n by 2. Okay, this is Rn, this is your 4 pi t n by 2. Okay, e to the power minus mod z square dz. So your, now your equation, this is now Rn. I will tell you how to do this. Phi of xt dx is nothing but, this is 40 to 40 pi by 1 by pi n by 2 Rn e to the power minus mod z square dz. Okay, clear? What is z? Z is z1 z2 dot 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 z. So mod z square is z1 square plus dot 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 plus z square. ठीक है? So what you will do, this is a, you can use the Tonelli's theorem, right? So you just have I1, I is given by Rn e to the power minus square dz. ठीक है? So you can use, so this is nothing but Rn e to the power minus z1 square into e to the power minus z2 square dot 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 e to the minus zn square dz1 plus, let me, I will write down dz. So these all are the positive function, all are positive function. This is a positive function, e to the power minus z square, right? You can use Tonelli's, you know Tonelli's theorem at least, you, the integration, you know Tonelli's theorem, or you did not know the Tonelli's theorem as well? You know Tonelli's theorem? Huh? Shami, Tonelli's theorem, Fubini's theorem, you have heard about it?
So we have heard about Fubini's, but not about Tonelli's.
You haven't heard about Tonelli's. Okay, Tonelli's means if the function is positive, you can change the order of integration. Okay, you understand?
Oh, okay, sir.
Same
Yes.
theorem, same theorem. This is also something known as Fubini. Same thing. Fubini. You can write down R1 R R1 e to the power minus z1 square e to the power minus z2 square. This is R z1, and you write down at dz1 dz2 dot 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 e to the power minus zn square dz. All are same, all are integral are same, e to the power x square dx in one variable. So I can write down as, this is R e to the power minus R sum, what you want to write down, x square dx whole to the power n, there will be n term, ठीक है, e to the power minus x square dx whole to the power n. So your I is nothing but all the n copies of e to the power minus x square, the multiply, right, by Tonelli's theorem. Now you know how to integrate this, at least this you know, e to the power minus x square dx. This you know, you write down I tilde. This you know how to do this? This you know?
Yes, sir. Yes.
How you do?
So like we consider another I tilde, then we
One part you can do, this is 2 times 0 to infinity e to the power minus x square. ठीक है? This you know? Okay. Now this is this is you write down I double tilde. This is 0 to infinity e to the power minus. You know this, how to do this? What you will do? You know how to do this? You write down I tilde
you said
tilde. What is meaning? E to the power x squared e to the power x squared dx. 0 to infinity, you know, right? E to the power minus x squared dx. You write down y. Same, इसका मतलब है y. e to the power minus y squared dy, right? Same thing. That's all. So this is 0. This is R2. Sorry, this is 0 to infinity. 0 to infinity e to the power minus x square plus y square dx dy. Again, I have used here Fubini or Tonelli. Now this is, you know how to do this, x square plus y square. You just put x equal to r cos theta, y polar coordinate. Okay. Do the integration. I don't know what exactly you will get. I tilde square. I think you will get pi you will get. I think pi. Yes. Pi. So I tilde is pi half, right? So this integral value is 2 into pi half. Okay, now come here. This value is 2 into pi half n, right? So this value is 4 pi n by 2. Okay, is that clear? 4 pi n by 2 exactly. This is equal to this integral value is, this is I have named. So this is, so there is some problem with 4, I think. Pi or this will get pi by 2, I think. I think pi by 2 we will get. Okay? If I'm not wrong, it will get pi by 2. I think, no. Maybe I'm making some constant mistake of this 2 somewhere. Okay, you just check. This one you check, please. Please check. Huh? I think I have. So it will be exactly 1. I think you will not, I think you will get exactly, because this 4 is there. I think you will get exactly 1. So I'm getting some problem with 1 by pi to the power n by 2 into 4 pi to the power n by 2. So this pi gets cancelled. So exactly we'll get 1 actually. I think I have made mistake here. This will be, I think, pi by 2 or something like that. Okay. So exactly we'll get. Okay. So this is the idea. So this is just using the Fubini's theorem. This is the idea. Okay. So this integral is 1. The integral of the heat kernel is 1. So this is crucially, it will be crucially used. Okay. That integration over Rn pi of xt dx equal to 1 for t. Okay. Heat kernel integral. Another. So a small lemma I can write. Lemma is phi, you know, C infinity of Rn. Phi is of course phi of xt. The fundamental solution. Rn cross R minus and solves Pt minus Laplacian phi is equal to 0 in Rn cross R minus, okay, and so this I have proved. The integral phi is 1. Do you need to prove this, or it is straightforward? Because how I have written down, already I have defined, right? 4 pi t to the power n by 2 e to the power minus mod x square by 4t, or t 0 when t is less than equal to 0. The only problem is this, where only problem is when x and t is 0, right? Only problem is when x equal to 0 and t tending to 0, or t equal to 0. Yes or no? What happened? Is that clear? What happened? What happened? Is that clear? Why it is C infinity or this one? So for t positive, there is nothing to prove. This is a very nice function. Smooth function, exponential, e to the power minus mod x. Only problem is x equal to 0, t equal. So that is why I have taken this number 0.12. Is that okay? Otherwise, if t less than 0, it's a 0 function. There is nothing to prove. Is that okay? Only function has a problem. It's not C infinity, where the problem is at x equal to 0 and t equal to 0. Is that okay?
Yes, sir.
So this is also trivial. And why this is trivial? Who will tell me? This you have to tell me why. Why? Why phi t minus Laplacian of phi equal to 0 in Rn cross R minus 0? Why? Look at the ODE I solved.
Yes.
Just you think about the ODE. This is, you forget about this. If you take the Fourier transform of this equation, just you take the Fourier transform, what you will get? You will just get this part. This is the equation. This solves this PDE, right? ODE, right? Yes or no? Forget about the 0. If t positive, then is that okay?
Yes, sir.
It's a trivial proof. Okay. So these three property I will be using all the time. Okay. This phi t minus Laplacian of phi equal to 0 in Rn cross R minus the 0.00 and integration phi of xt equal to 1 for t positive and phi is this a C infinity function except 0, 0. Clear? Now you write a beautiful theorem which I am going to prove is the following. Let G is CRn, continuous function Rn with bounded also, continuous bounded function. Because it is Rn, so only continuity will not guarantee the boundedness. Okay, so G is C infinity R. Then the function okay will satisfy which equation? Can you tell me what type of equation it will satisfy? Phi is the fundamental solution. Then what it will satisfy? Huh?
I think heat equation having the boundary as G.
Very nice, very nice, very nice. So I will satisfy number one. U is C infinity. Okay. Then equation minus Laplacian of U equal to 0 in Rn cross 0 infinity, and it will satisfy limiting boundary condition. That limit xt tending to x naught 0 uxt is equal to x naught. So this completely, so suppose you are given, you want to solve this equation, then what you will do, you just take phi, you just translate with x minus y comma t, and then multiply with gy and integrate with respect to y. Then this will solve the heat equation, and also it will satisfy the boundary condition, provided g is a continuous function in Rn, and also it is a bounded function, L infinity function, not exactly the bounded L infinity function. Is that okay? Clear? Now I have to prove this. It's a big theorem, like the way we prove for the what we have proved for the Laplace equation, right? So let's do that. So do I need to prove that U is a C infinity function? Anyone? Please tell me. Do I need to prove that this is a C infinity function uxt? Please tell me. It's a triviality. Why it's a trivial? Can you tell me?
Is kind of a convolution of phi and G and
Exactly.
phi
And
is
T
C
is a
infinity.
very smooth form for T positive, of course. So there is nothing to prove. One is trivial. 1 is trivial. For some fix, or some, just I am writing for some fix t naught positive, phi and all its derivative and all its derivatives are bounded and integral. In Rn cross T naught. So you just take a, because the problem only at 0, right? You take a little bit of positive distance, T naught. You fix some T naught positive and all are positive, and you pass the limit and everything will be trivial, right? Similarly for all is derivative of phi. Since, next step, since, and it's a convolution, is a smooth, since T naught is arbitrary, right, we get U is C infinity in Rn cross open 0 infinity. Okay, because of T naught. Okay. Second part, how to do the second part? Ut minus Laplacian of u equal to 0. Just use this property. Let's prove this because t is positive, so we are safe. So what is given? U of xt is given to be t of x minus y comma t gy dy. Okay, what is ut at the point xt? Just use the definition of integrate this one. This will be Rn phi t x minus y t gy dy. Okay, straightforward. Then what is Laplacian of x? U of xt. This is Rn Laplacian with in x variable phi of x minus y comma t gy dy. So what is ut minus Laplacian x uxt? This is nothing but Rn phi of x minus y comma t minus x variable phi of x minus y t t positive. So what is the value of this? Anyone? T is positive. So this function only has a problem when x equal to y and t equal to 0, because you know phi of xt. It has only problem when x equal to 0 and t equal to 0. Otherwise, it's a smooth function and it satisfies this equation. For open 0, it's not 0. There is a problem. Otherwise, it's a very not this one. This one. This 0 0 has a problem. When t and x both are 0, then it has a problem. Otherwise, it will satisfy this equation. So just tell me when t is so this equation only is non-zero. Only it is non-zero when x equal to y and t. This is x equal to y and t equal to 0. The only problem. So this is what will be the value of this? Sorry, t. Phi t x minus y t minus. What will be the value of this? Huh? Phi t at any point xt in Rn cross R minus 0 0. Any point xt it is 0. You phi t minus Laplacian of p at the point xt equal to 0. So what will be this? This x minus y is any point. So it will have only problem when x equal to y and t equal to 0. Otherwise it is 0. This implies ut minus Laplacian equal to xt equal to 0 for Rn cross 0 infinity. Of course, t positive is important. Okay. Now the difficult part. We want to show that limit x tending to 0 uxt equal to gx naught. What does it mean? It means is that now we want to show the third part. Now want to show that limit xt tending to from x naught 0, t positive, of course, from the above, uxt is equal to g. Just draw the picture, then it will be clear. This is your Rn, this is your t. So some fixed some point x naught. So t positive xt, that means it should come from above. So this says that when xt coming to the is converging to x naught comma 0, then uxt is equal to, it will converge to gx pointwise sense. In a pointwise sense. This is a pointwise. In a pointwise sense. Okay. That means I have to show. So you have to take uxt minus g of x naught. What is uxt? This is Rn p of x minus y comma t gy dy minus g of x naught. Which trick I will use now? Any idea?
I know that integration of phi is 1, so I can write gx naught as
Exactly.
4 and then use continuity of g.
Comma t dy. This is Rn is 1. Okay, so I can write this as Rn p of x minus y comma t gy minus g of x naught. Okay, so we have now uxt minus g of x naught modulus. This is modulus Rn p of x minus y comma t gy minus g of x naught modulus. So this is less than Rn p of x minus y comma t gy minus dy. So what I will do? What I will do? As xt going to x naught. Now tell me what I will do. Any idea?
Consider a ball of around x, small ball, and then like I can add sum of two integrals.
You take y very close to x naught. Yes? Yes or no?
Yes, sir.
Let epsilon positive, there exists delta positive such that gy minus g of x naught is less than epsilon whenever y minus x naught is less than delta. So when y is very close to x naught, I can always make gy minus x naught delta. So what I will write down, this integration. This is Rn p of x minus y t gy minus g of x naught dy. This you write down in two parts. Okay, this is a trick you should understand. B x naught delta, this is phi of x dot 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 plus b x naught delta p of this whole integration. Okay, so I make this Rn in two parts. One is bx naught delta, another is bx naught delta complement. Is that clear? Is that clear?
Yes, sir.
Okay. Okay. So how to bound this one? Phi of x minus y t g of y minus g of x naught. Y is close to x naught. That means g of y minus x naught is less than epsilon. Less than epsilon b x naught delta phi of x minus y t dy. So this is less than equal to 1 because the whole integral is 1. Phi is a positive function, so it will be less than equal to 1. Yes or no? Integration over Rn phi of x minus y comma t dy is 1 independent for any t. Yes or no? Then this set is smaller set and phi is the positive function, so this will be less than equal to, or you can write down Rn is a positive function. This is equal to 1, so this is less than epsilon. Clear? This part is clear? Yes or no? Can you hear me?
Yes, sir.
There is a power cut here, so in IIT. Just a minute. Sorry, just a minute. Sorry, this is gone out. Just a minute, wait. What is the problem? Just think how to do the left out portion. Bx not delta complement. How to tackle this? Any idea? Huh? Can you hear me?
Yes, sir.
So can you see the white page?
Yes, sir.
Okay. Now we have, because all the pages has gone now. Have gone other pages. Anyway, so now we have to now we have P x naught delta complement P of x minus y comma t gy minus g of x naught. How to tackle this? So one way is g is, you know, g is given to be L infinity, right? So this is less than some constant to m, because mod of g plus mod of gx naught, right? Yes or no? Yes or no?
Yes,
Yes
sir.
or no? Okay. Now what will be this? This is very interesting. Let me write down first. What is this? If I write down in the value of phi xt, this will be 4 pi t. This is y minus x naught greater than delta, because complement, y is the complement, right? E to the power minus x minus y whole square by 4t dy. It is given that mod of y minus x naught is greater than delta. Okay. What you can do, since you remember we have to show that xt going to x naught comma 0, right? Yes or no? Then we have to show that u of xt limit goes to u of, sorry, g of x naught. Yes. Now you tell me xt x going to x naught means x minus x naught will be less than, I can make always less than delta by 2. Yes or no? Since xt going to x comma 0, I can always make x minus x naught less than delta by 2. Yes or no? Huh?
Yes, sir.
Yes, sir. So what will be value of y minus x now? Y minus x is greater than equal to triangle inequality. Y minus x naught minus x naught. Yes or no? Yes or no?
Yes, sir.
Yes, sir. Y minus x is greater than delta because this is, and x minus x naught is less than delta by 2. That is minus will be greater than delta by 2. Is that clear? Whenever y minus x naught is greater than delta and x is very close to x naught, I can always have y minus x greater than delta by 2. Not x naught. This is x. Is that true? Is that okay?
Yes, sir.
Okay. That means this set of all y such that y minus x naught is greater than delta is contained in the set of all y minus x greater than delta by 2, provided x is close to x naught. Clear? Clear? This
Yes,
set
sir.
of all y such that y minus x naught is greater than delta is contained in the set of all y such that y minus x is greater than delta by 2, provided x is belongs to x naught delta by 2. Provided. Is that true? Clear? Okay. So which is less than equal to 1 by 4 pi t n by 2 integration y minus x greater than equal to delta by 2 e to the power x minus y whole square by 4t dy. Okay. ठीक है? Which is equal to, I can write down as 1 by 4 pi t n by 2 mod z greater than delta by 2. Mod z I have put it right. Z square by 4t. Z I have written down x minus y. Sorry, z equal to x minus y. Okay, so we have 1 by 4 pi t n by 2 y minus x naught greater than delta e to the power minus x minus y whole square by 4t dy is less than equal to 1 by 4 pi t n by 2 mod z greater than delta by 2 e to the power minus mod z square by 4t dz. This I have proved. Okay. Now you do the substitution. Z is equal to root dy. Then you will have dz is equal to t to the power n by 2 dy. If you do this, then it will be 1 by 4 pi whole to the power n by 2 mod y, because z is there, so mod y will be greater than delta y 2 root t e to the power minus mod y square by 4 t y. ठीक है? Is that okay?
And so like in the initially we take z equal to y minus
Yes.
like in the first substitution.
In the first substitution, z equal to x minus y. Yes.
Like x minus y minus x.
Sorry. Oh, okay. You name different name. You y bar. Okay. So this y and
No, actually I was saying like initially we have taken z equal to x minus y. Instead of that, shouldn't we take y minus x?
no. This y and this y are different. You take y bar. Okay.
No, so like the sign will change. Initially, like we have.
Okay. Take y minus. Okay.
Yes.
So this y and y are different. Now tell me, when t is going to 0, where this function will go? Tell me.
Goes to like 0.
Again, light off. Just a minute. Again, light off. Yes. Can you see? Are you able to see?
No, sir.
No, sir.
No. Now you can see?
Yes, sir.
Okay, good. So now as I'm asking for this equation, just see the integral. Right hand side, this side, this one. As t tending to 0, where this integral will go?
This goes to 0 because the whole integral converges and we are considering the outer.
Why?
So like the whole integral we know it's convergent and we are like
Very good.
decreasing the.
Very good. Right. This is an exercise in measure theory. I'm sure you have done this. This you can't say that you haven't done. If f is in L1 function, limit r tending to infinity, mod x greater than r, this will be 0. Here, of course, this f is here this function. This is a L1 function. As t goes to 0 means mod y is this, let's say this is like rt goes to infinity as t tending to 0. So you apply this goes to 0. So this integral is 0 as t tending to 0. Okay? So you have proved that this imply, and other one is epsilon. So xt uxt minus g of x naught is less than equal to epsilon. This implies limit xt tending to x naught 0 xt. So this function uxt g of x minus yt gy dy solves ut minus Laplacian of u equal to 0. You will see infinity first, second, and third. That limit xt tending to x naught 0 uxt is equal to g of x naught. All three is done. Clear? Is that clear? Okay. Now what you have solved is the homogeneous equation, that ut minus Laplacian of u equal to 0 and the boundary condition is given to be gx. Now the thing is that we will be studying something opposite, that if g is 0 and the equation is non-homogeneous. Now instead of 0, you have f. Then how to solve this? Okay. What are the equation? What are the solution? The proof is very similar. Okay. That is the famous. This is a famous theorem known as Duhamel principle. Duhamel. Let f is a C. I will tell you what is that. C2 C1 with compact support. Rn cross 0 infinity. Define uxt as then uxt satisfies. Now you have a translation in y as well as translation is a time variable with f of y as two variable function. Okay, then uxt will satisfy one. First of all, uxt is a C21. I will tell you what is C21 function. Means C2 means in x variable is a C2 and in t variable it is C1. Okay? And continuous, and it has a compact support. That means the support has a compact. This function has a compact. It means you know what is the compact sets in Rn cross 0 infinity. That C means it has a compact support. But of course, uxt once I translate with x minus by t minus, it may not have a compact support. Rn cross 0 infinity. This is triviality, nothing to prove. Ut, it will satisfy ut minus Laplacian equal to f of xt as xt. And the third one is limit xt tending to 0 for all x not in Rn. That means now you have a solution. Now ut minus Laplacian of equal to fxt and the boundary is 0. Then the solution is given by then uxt solve this equation. Is that okay? Is that okay? The theorem, what theorem says that at least the statement of the theorem is okay? Just think about it. Is that okay?
Yes, sir.
Okay. So do I need to prove or you can prove this? What? Okay. May I go fast, little bit fast, so that you can understand? Huh? Proof is very similar to the last one.
Okay, sir.
Let me explain. You have uxt 0 to t Rn. I just write now p of ys f of x minus y t minus s dy ds. How can I write this from here to here? This uxt is this. How I am writing this is equal to 0 to t. How? You just tell me. Rn p of ys f of x minus y t minus s dy ds. How I am writing this is equal to this. What substitution I am putting? Huh? You put
You
y.
translating the measure.
No, yes, you just put y equal to x minus y. And you understand x minus z you put. Okay? Similarly, s equal to you put some t minus t1. Okay? You just put this. You will having z and t. So it will be, if you put this will be, you know what will be this t 0 to t bar 0 to t bar, minus will be there, Rn, translation invariant, everything, p of z t bar, f of, you know what is that, x minus z bar, and dot dot dot. You just now put z and t bar as these are the z and t bar as the variable, right? Z and t bar are the variable, so you can put z and t bar as well as y and s as well. You understand? So I have just change of variable. Is that clear? What happened? Is that clear? This is a very simple argument.
Yes, sir.
Let's put y equal to x minus z. So this will be z comma t. Sorry, z comma t bar. This will be p of z comma t bar. This will be f of x minus z t minus t bar dz dt bar. So z and t bar are the variables. So instead of z, you now put this, you put y. You understand, right, what I am saying? Because these are the running variable. These are the variable now, dz and d. So instead of z and t bar, you can put y and t. Okay? Y and s. Sorry, y and s. So this, just rename it. Rename it with z and t bar as y and s. Y and s, and this will be y and s again. Okay. So this is just a change of variable. Okay. Now what will happen? Ut at xt is 0 to t Rn p of y minus s t minus s dy ds plus why this I have written down. Anyone? Any understanding why? When I take the derivative, why this plus this? You know differentiation under the sign of integration? Anyway, you check. Everything I cannot tell you. U at xt so ut minus Laplacian u at the point xt will have ft okay. Is that clear? I just ut minus, I just subtract these two part and you subtract. So yes, so this part plus this part. Okay? Is that okay? So now this I will write, this integral I will break in two part. 0 to epsilon Rn plus epsilon to t Rn plus this integral. Okay? This part you write down A, this is B, and this is anything. So you have So you have what is A? A is nothing but 0 to epsilon Rn P of y comma s ft x minus y t minus s minus x f of x minus y t minus s dy ds. Okay. Okay. What I will do now? This is less than equal to what I will do. F is given to be, just remember, F is given to be C21 with a compact support. What I can do now? In the space variable, it has a C2, and in time variable, it is C1, and with a compact support. So what I can do now? Huh?
So like this Rn will be replaced by complex set, and being continuous on complex set, I can bound it.
Yes. Whole thing. This is take the modulus, so it is mod plus everything less than equal to some m times 0 to infinity Rn P of ys dy ds. This integral is for any s. What is the integration? Rn phi of ys dy.
For positive, it's 1.
1.
Yes, sir. For positive s, it's 1.
Sorry. S is positive. See, 0 to epsilon.
Yes, sir.
You can take s to be into epsilon 1 ds. This is m times epsilon. Which you can take epsilon by m or something like that. M can be epsilon. Okay. A is done. What will be now B? Hmm? क्या होगा? What will be B? How to do this? This I can write. Just see what I can do. I have this derivative with respect to t. I want to make it derivative with respect to s. What I have to do? क्या होगा? What I have to do? What I have to do? Is that okay? With respect to s, minus will pick up. With respect to minus y, this will be plus y. Just change out the variable. Is that okay? What happened? Is that okay? T and s both are independent variables. So if I want to do it with respect to s, then what will happen? If I change to t to s, what will happen? Yes or no? Ft plus fs equal to 0. Yes or no? What happened? Is that clear? Shammi, clear?
And so the Laplacian we are taking the.
See, this is the derivative with respect to time. T, this variable t.
Yes, that part is clear. Like that it will be changed into minus of fs.
Same with respect to x also. Sorry. ठीक है? Because both two derivatives are there. No, so the same minus sign will be there, right?
And it will be with respect to x.
Now I have taken with respect to y. So one derivative minus y, same minus y. ठीक है?
Okay. Yes.
Now what I will do? Now do the integration by parts to y. First derivative you take here, Laplacian y is there, epsilon to t. So there is no problem. Phi is a very nice function from epsilon to t. That is why I have put epsilon here. You understand? That is why I break epsilon, because phi has a problem when y and s are both 0, right? Phi has a problem when y equal to 0 and s equal to 0. So we have to be careful around that point. So I have taken now, if t is your epsilon to t, so s is from epsilon to 2, so s never goes to, for fixed epsilon is positive, s never goes to 0. So for any Rn, this can be a C infinity function. Okay. Now do the integration by parts. Of course, the t and epsilon boundary term will be there for fs integral. So this, if I write down, this will be epsilon to t Rn ds minus Laplacian by phi at the point ys f of x minus y t minus s ds. Okay, and if I go on this, so see, this term is there, this will cancel out with this term. Okay, so let me write down, then you will understand. So ut minus Laplacian u at the point xt is equal to a plus b plus Rn phi of yt f of x minus y 0 dy. This is because a is less than m into epsilon. What is b? B is epsilon to t Rn phi s minus Laplacian phi the point ys f of x minus y t minus s dy ds minus Rn phi of yt x minus y comma 0 dy plus Rn phi of y comma epsilon f of x minus y t minus epsilon plus Rn phi of yt. This gets cancelled, this gets cancelled. So this, and what will be this term? Who will tell me? What will be this term? S is from epsilon to t. What will be this term?
0 because phi is fundamental solution.
Exactly, this is 0. So this is 0. So you have now less than f into epsilon plus Rn p y comma epsilon f of x minus y t minus epsilon. Now this will converges to f of xt as epsilon goes to 0. Why? Why? How to do this? Shall I give you for exercise? Shall I give it for exercise? Simple, very simple.
Like convolution kind of thing. So
You just write down properly, not even
yes.
just write down. See, you just write down like this. You just remember that f is continuous, right? Where this will go as epsilon goes to 0, f is with a compact support. This will go to as epsilon goes to 0. This will go to
0.
Now your integral left with this phi epsilon. So this we have done already, right? In the last theorem. Remember? What happened? Remember that uxt goes to g of x naught as xt goes to x naught comma 0. Yes or no? So this will convert this to, just check. Okay? Just check and you will get it. Okay? Is that okay?
Yes, sir.
Okay. This will come then. So, so I can write this two theorem. So I have proved two theorem today, right? So I can make this two theorem into one, and I prove like this. That let F is a C21 with a compact support Rn cross 0 infinity, comma G is a continuous function with Rn, means both the non-homogeneous, right? Then the function uxt defined by 0 to t is in C21 blah 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 solves this equation. Okay, so this uxt 0 to t Rn fundamental solution with phi xt into gy will solve this. That's all. One more class on heat equation. We will do a little bit advanced, one more maximum principle kind of. We already have a maximum principle for a bounded domain. If you remember that omega is crucially used, the fact we have used the fact that omega is a bounded domain. Okay, but now we will show that next class I will prove that if omega is Rn with some appropriate assumption on u, we can also prove the maximum principle. Okay, that's all. That's all. Then I think we have two more classes left, right? Yes or no? I think we have two more classes left, right? Shammi, Ankit, and Ekansh. Shammi,
Yes, sir.
so one class I will do
Yes, sir,
this
next week.
next week. Yes, next week two more classes. So next class I will finish heat equation, one more maximum principle and little bit of regularity theory. And then last class I will do some little bit of wave equation, and then I will stop. Okay, and this week also I will upload some assignments so that the tutor can do some assignment on heat equation. That's it. Okay, thank you. And I will try to finish the quiz correction quickly. Thank you.
Okay, sir.
Thank you.